Hello, we are Teammate. Our solution is an automatic diagnosis of the electrical power grids using image recognition. First, we want to introduce ourselves. We are Oscar Arbeláez, Sebastián Salazar, Julián Porras, Santiago Rojas, who is speaking Andrés Ospina, and Johan Greso. Although we work together in all the stages of the solution, we divided our group in three subgroups, focusing in different things of the solution. The first two groups were focused on the image recognition challenge. Oscar Arbeláez and Sebastián Salazar were focused on training a YOLO model from Ultralytics. Julián Porras and Santiago Rojas were working on a fast RCNN model. And Andrés Espina and Johan Creso were working on a web app to deliver a full, complete solution that can be deployed right away. Some of the biggest cities in Colombia are located in the Andes Mountains. This gives them a great beauty, but it also brings some challenge. The electric utility provider, EPM, struggled with this topography to do the maintenance of the transmission towers that often are in places hard to reach. For this reason, EPM started to take photos with drones and then manually inspect thousands of pictures to determine if a component needs to be repaired or replaced. This process is slow, boring, and open to human mistakes. This makes this process to be expensive and not scalable. An automatic inspection of the electric grid can detect problems on 1,000 images in just a few seconds. This makes this available to scale in the whole network, and it reduces cost and it increases the speed of response with the maintenance of the electric grid. So let's see how our application looks like. Let's say we want to identify in this tower which of these insulators need to be repaired or replaced. So first, we upload an image and it automatically detects where the picture was taken and to which tower it belongs. It also runs the model and identifies the components on this picture. And we can see here that we get all the insulators of this tower. Everything is getting with the tag 0, that's mean insulator in good shape. And we can see that it gets with the tag 2 the transformer as well. So what happens if we upload a lot of images? We can see that all the components are, all the information is loaded to this table, and we want to identify which one of these picture has a bad insulator that needs to be repaired. So we see here 3 bad insulators, and we check the image, and we are looking for a tag 1 bad insulators. So we can see here in tag 1 that it detects 1 bad insulator. This insulator, the lack of painting here is not good, so it needs to be changed. We can see here as well that we have some scratches and some loss of the ceramic painting. So these insulators need to be repaired. After we end up checking for all the network, we can download this table to Excel. So we can send it to the service to the maintenance department so they can deploy a service and change these insulators. After you are done here, you can clean up your workspace and start over again. So what's behind the application? First, we upload the image, and from that image, from the metadata, we extract the GPS location. With this location, we then identify if this image is within a 20 meters radius from a transmission tower. And now we have associated the image with a component of the electric network. Now we have to identify the elements of the transmission tower and identify if they need maintenance or not. To do that, we pass the image to a convolutional neural network that recognizes and classifies the components of the transmission tower. With this, we can now display a maintenance order so the bad components can be changed, cleaned, or can be repaired. What's the performance of our model? The model works very well detecting insulators, even when they are hidden by other insulators. The model detects around 93% of the brown porcelain insulators, which is the one that has the most samples. In the case of damaged insulators, the cracks are accurately detected, but there are other types of damage that they're not so good detected. This is because we didn't have enough image for the model to learn about it. And this is one thing about convolutional neural networks. It would only detect the problems that you trained it for it. So in order to make better predictions, we need a lot of images in the whole range of problems that can be found in the insulators. Our model can also identify insulators in lifetime videos. This can be installed directly on the drone or on a computer nearby where the pilot of the drone is. This way, if a detection is noticed, the drone can focus on confirming the damage, improving the accuracy. In these videos, we can see how the insulators are detected by our model. Our solution is only the beginning. We need to improve even more the precision of the model by including more images into the training process. Also, if a better machine is used, the model can be trained with higher parameters, and that helps a lot in the precision. To completely deploy this solution, our model needs to be trained with all the components of the transmission towers and with all the damages that these components has, and with enough images to do a good job recognizing these problems. This web app can be also integrated with a maintenance software to automatically send a work order to the zone responsible when a detection is noticed. Using video in the inspection of the tower can improve also the accuracy of the predictions. Finally, we want to thank you. We want to thank Mintic for this opportunity. We want to thank Data Science for all the knowledge and all the information. And we want to thank EPM for this challenge and for being with us through all the process, giving us all the information we needed. So thank you.